Suppose that one family kept track of how many DVDs they rented each month for a 2-year period. The numbers for each month are shown in the table below. Make a box and whisker graph from this data. Okay, well, we already put them in order yesterday, and we found the 5-number summary. What things make up the 5-number summary? Right, the minimum, the maximum, quartile 1, quartile 2, and quartile 3. What can we also call the minimum? The lower extreme. What can we call the maximum? Upper extreme. And then, of course, these are all quartiles. Which one do you have to do first? Quartile 2, because that's the median or the middle of all the data. And you have to find it first so that you split the data in half. Then quartile 1 is the median or the middle of the lower half. Quartile 3 is the median or the middle of the upper half. What was our minimum from this data? What was our maximum? What was our quartile 1? Quartile 2? And quartile 3. Okay, Anna, you have a question? I don't. You'll have to go to another room or you borrow a pencil. Okay. Shh. Now we're going to actually construct the box and whisker graph. The first thing that you have to do is you have to number your number line. Now, we know that our numbers have to go at least from 0 to 15. So if you start at 0, you should be able to fit all the way to 15 on your number line. Okay? And we don't even have to use the entire number line because, yes, otherwise it's going to be hard to construct your box and whisker plot with no numbers. Okay, first we'll draw in the whiskers. The whiskers go to the minimum and the maximum. Well, if there's a minimum at 0, I'm going to put a point at 0. And there's a maximum at 15, so I'm going to put a point at 15. Then you construct the box with your 3 quartiles. So at 2.5, I'm going to draw a line. At 4.5, I'm going to draw a line. And at 8. And then after you have your 3 lines representing your 3 quartiles, you will just connect them to make it a box. And then you will also connect the box to the whiskers. Okay, so that is the box and whisker graph for this data. How much data is in the box? 50% of the data, because 25% is from the whisker to quartile 1, 25% is from quartile 3 to that whisker, so the remaining 50% of the data is in the box. Any questions?
No. It's called...
Okay, now, another thing that we didn't talk about yesterday that you need to be aware of, you all know how to calculate range. What would the range of this data have been? 15, because the maximum is 15, the minimum is 0, so when you subtract them, you get 15. Well, there's also something called interquartile range, and it's abbreviated IQR. What do you think you would do to calculate the interquartile range? Right, Q3, you might want to write it below it, Q3 minus Q1. Q3 is 8, and Q1 is 2.5, so what is the IQR? 5.5. Okay, because 8 minus 2.5 is 5.5. Okay, now turn to page 7. For question 25, refer to the box and whisker graphs below that show the average monthly high temperatures for Milwaukee, Wisconsin, and Honolulu, Hawaii. So here's a box and whisker graph that shows the average monthly high temperatures in Milwaukee, and here it is for Honolulu. you need to compare them and write down a few statements that you recognize from the box and whisker graphs. Go ahead. Okay, who can tell me one thing they notice about both cities?
And Milwaukee. Milwaukee has a wider.
Okay. Milwaukee has a greater spread. So in Milwaukee, the range would be much larger of a number and the interquartile range would be much larger because it has a greater spread. Now, that is really called greater variability. The box and whiskers graph. Well, the data is more spread out, which means it has greater variability. Okay, what else do you notice?
The highest temperature is 80 Milwaukee.
Okay, they just, really, you could say anything, like everything y'all are saying is right. You just say anything you want that you notice, like Milwaukee has a lower, or you could say, yeah, Milwaukee has a lower median temperature. Than Honolulu. Because what is the median temperature in Milwaukee? 57. What is it in Honolulu? 84.5. Correct. In Honolulu, your mean and your median would be much closer than in Milwaukee. The mean would be below the median. Okay, you can write down anything you want here. Okay, you could write down Honolulu's maximum temperature is higher and Milwaukee's minimum temperature is lower. Just anything that you read from the graph you can write down. Does everybody understand now? Question 26. Well, hold on. Okay, question 26. In the table below, the average monthly temperatures for Pullman and Seattle are shown. Draw a box and whisker graph using the same scale for each city from the data. Then write a short paragraph summarizing what your graphs tell you. Okay, so like on the first number line, that's where we'll put the data for Pullman. On the second number line, that's where we'll put the data for Seattle. Okay, they also want you to use or to number your number lines using the same scale. So whatever you number the top one, you have to number the bottom one. Well, let's look over here and see what we should start our number line at. What is the lowest temperature? Right, your lowest temperature is in Pullman and it's 34.5. There's nowhere lower. What's your highest temperature? Okay, where is it? Over here? So, even though Seattle's averages do not go that low or that high, we still have to use the same scale. So, we need to start at 34 on both of them. And then our goal is to make it all the way up to 82. So, do you think you can do that going by twos, like 36, 38, 40, 42? Because they say use the same scale. You could, but yeah, threes is better. Okay, you can't go by twos because you would have run out of room. You would get over here and stop in the 70s and you're trying to make it 82. So we need to jump by threes. Now, because I can't cram all of those numbers in, I'm going to write every other number. So if that's 34, this is 37. So this would be 40, 43, 46, 49, 52, 55, 58, then what? 61, so I write 64, 67, so 70, 73, 76, 79, 82, 85, 88, and then that's enough because we only have to get up to 82 anyway. Okay, so now number your bottom number line with the same numbers. Wait till we're done with this one. Shh. Be quiet. Okay, now we obviously have to have some data to be able to construct the box and whisker plot. So we need the what? Correct, which is called the, right, we need the 5-number summary for each city. So on this first line down here, I'm going to write the 5-number summary out for Pullman. And on the second line, I'm going to write it out for Seattle. Okay, and remember, the 5-number summary consists of a minimum, a maximum, a quartile 1, quartile 2, and quartile 3. Now, the other day when we were learning about mean, median, mode, and range, the measures of central tendency, I taught you how to put the data in the calculator, and it would tell you the mean. It would tell you the median. It didn't tell you the mode, and it didn't tell you the range, but it would tell you the max and the min. Well, isn't the max and the min two things we need to find? It'll also tell you your quartiles. So let's go to the calculator and put this data in. How do you get there? Does anybody remember? Stat. Then what? Edit. Remember, if anything is already typed in your list, you go up until you've highlighted the list you're in, hit clear, and then go down and it'll disappear. I'm going to put the Pullman averages in list 1 and the Seattle averages in list 2. Okay, so all of my Pullman averages I'm going to go ahead and type in list 1, and my Seattle averages I'm going to type in list 2, okay? Okay, has everybody had a chance to type in both averages? Okay, once you have your list typed in, what do you do next? Correct. One variable. Okay, but look, right now, we're doing the list L1. So right now, we're looking at Pullman averages. So go down and click calculate. We see the mean temperature, the average temperature is 57.4. The minimum is 34.5, which we kind of already knew that. The maximum is 81.9. Oops, I wrote that in the wrong place. Hold on. Okay, and then it does give you the quartiles. Quartile 1 is 42.1. Quartile 2 is what? Right, it doesn't say Q2, but it says median, which is the same thing. 57, we'll just round it to 57.9. And then quartile 3 is at 72. Okay, now we need to find the 5-number summary for the Seattle averages, but they were in list 2. So watch so that you see this. Go to Stat, Calc, one variable. However, it still says L1. Do you see down here above the 2 button, it says L2? But to get it to use L2, what do you press first? So second, L2, and then calculate, and it'll do the data in list 2. Okay, so the average temperature in Seattle is about 61 degrees. The minimum is 44.7. The maximum is 76.9, right? Quartile 1 is, we'll just round it to 51.1. Quartile 2 is, right, so it'll round up to 60.4, and quartile 3 is, right. That's a lot easier to do it in the calculator than having to write out the list and find the middle and then find the middle of the lower and the upper, right? Okay, so now to put them on there, remember the minimum and the maximum are whiskers, so we'll put dots to represent them. So for Pullman, the minimum is 34.5. So if that's 34 and that's 37, 34.5 is basically going to look like it's sitting at 34. The maximum is 81.9, which is going to look like it's sitting at 82, right? And then you draw lines for your quartiles to make your box. Okay, so quartile 1 is 42.1. So let's see, if that's 40, that's 43. 42.1 would be a little closer to the 43 line. 57.9 would be about right there. And then 72 would be about right there. Okay, and then you just close in your box. And then you connect your box to your lower extreme and your upper extreme, and those are called the whiskers. That's all you do. Okay, so now let's construct the box and whisker plot for Seattle. The minimum temperature in Seattle was 44.7, so that would be about right there, because that's 43. 76.9 is the max, so that would be about right here. And then quartile 1 is at 51.1. Okay, then 60.4. This is 61, so 60.4 would be before that line. And then 71.1 would be about right there. So which city has greater variability? Pullman. The data is more spread out in Pullman, so Pullman has greater variability. Which city has the smaller IQR? Seattle, because remember, IQR is the range from Q1 to Q3. Well, from Q1 to Q3 in Pullman is much larger than Q1 to Q3 in Seattle. Which city has a higher median? Seattle. Seattle's median is what? 60.4, and Pullman's is only 57.9. Okay? Any questions so far? Alright, now turn to the next page. For questions 27 through 35, refer to the following data that shows the total number of points scored in each of the Rose Bowls from 1970 until 2006. Make a box and whisker graph for the total points scored in each decade. Make sure your 4 graphs are drawn with the same scale so that you can compare them. Okay, so what am I going to call each of my 4 box and whisker plots? Like, what should this one be about? We're comparing the decades, right? Well, the first decade we have is the 70s. So this one's going to be about the 70s. So the next one will be about the 80s, then the 90s, and then the final one will be 2000s. Okay. Now you are going to construct a box and whisker graph for each of those. So you can go to your calculator and you can type in all the data at once, but like all of the 70s would go in L1, all of the 80s would go in L2, 90s would go in L3, 2000s would go in L4. Okay, so go ahead and type in all the data. So once your data is entered for each decade, you hit Stat, Edit, not Stat Edit, sorry, Stat Calc. But look, right now it's looking at what list? We want to look back at L1, so how do we do that? Second and then 1. We'll pull up L1 and then calculate it, and let's write down the 5-number summary for the 70s. Okay, so for the 70s, I'm just going to write it right here small. The minimum was 13. The maximum was, so what's the range of the data? But what's the range?
The range is
50. 63 minus 13. Q1 is 25. Q2 is,
27.
Q2 was what?
Q2 is 34.
And Q3 is,
47.
okay? So that's the 5-number summary for the 70s. Now let's do the 5-number summary for the 80s. So go back to your calculator, stat, calc, one variable, but now what do I need to do?
2.
Put in list 2, so second 2, and then calculate. Okay, the minimum is 28. The maximum is Q1 is, Q2 is, and Q3. Okay, now we need to do the 5-number summary for the 80s. So we go back to the calculator, stat, calc, but we need to look at list 3. So second 3, L3 is above the 3. Calculate. The minimum is 27. The maximum is, quartile 1 is, quartile 2, and quartile 3. What is it? Yep. Okay. Now for the 2000s. Stat, calc, and then you have to change that to list 4, so second 4, because L4 is above the 4. Then calculate. What's the minimum? The 26. What's the maximum? Quartile 1, 45. Quartile 2, I mean, yeah, you could round it to 51. And then we'll round this one to 67. Okay, so does everybody understand how to use the calculator, type in the data to find the 5-number summary? Okay, so now we need to decide how we're going to number our number line, because they ask that we do them all on the same scale so that we can compare the data. Because if they're done on different scales, it doesn't make it easy to compare them. So what's your lowest number of all the data? 13. What's your highest number? 79. So we need to try to make it from 13 to 79, or you could go from 10 to 80. If you go from 10 to 80, let's go by, well, no, that will be too short. Yes. Go by what? So like this would be 10, 15, 20, 25, 30, 35, 40. Oh, but will that fit? All the way up to 80? Oh, okay, yeah. I mean, if it'll fit, you can do however, but I'll just keep going like this. Like this is 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay, and remember, they all have to be that same scale, so you can go ahead and number all of them that scale. Yep. Okay, once you have them numbered, I want you to construct your box and whisker graph on each one. Okay, so once they're numbered, you should be able to construct the box and whisker graph yourself now. The minimum and the maximum are the whiskers. The Q1, Q2, and Q3 are the lines that make the box. So go ahead and construct your box.